Modern DNA technology and genetic genealogy have transformed cold case investigations. Blood footprints, once static, now reveal DNA profiles, identifying suspects decades later. This evolution in forensic science not only revives old cases, but also provides justice for victims, demonstrating the enduring power of physical evidence in solving mysteries.
Physical evidence, such as blood and fingerprints, can endure for decades, preserving vital information. Modern technology can now extract data previously unattainable. Re-examining evidence often uncovers overlooked details, transforming dead ends into leads. In our case, blood footprints held DNA secrets, ultimately identifying the perpetrator, showcasing the enduring power of physical evidence in solving cold cases. The case of the young woman found murdered in her apartment, marked by distinctive bloody footprints, highlights the challenges of cold cases. Despite exhaustive efforts, detectives failed to identify a suspect. Blood evidence was preserved, waiting for technological advances. For 30 years, the family sought closure, illustrating how time can hinder and eventually aid justice. In the 1990s, DNA testing required large, high-quality samples and could only match known suspects. The advent of polymerase chain reaction amplification allowed analysis of smaller, degraded samples. Combined DNA index system and other databases automated DNA comparisons. Modern genetic genealogy now uses advanced sequencing and genealogical research to identify suspects through distant relatives, even without prior criminal records. Forensic genetic genealogy revolutionizes investigations by extracting DNA from minimal samples and sequencing numerous genetic markers. Profiles are compared in genealogical databases, identifying relatives with shared DNA segments. Genetic genealogists construct family trees, tracing common ancestors to pinpoint suspects. This method expands the investigative reach beyond direct matches, leveraging voluntary DNA submissions to identify suspects through their relatives. Investigators re-examined blood footprints, discovering a mix of the victim's blood and the perpetrator's skin cells. Advanced DNA extraction isolated these profiles, allowing genealogical databases to identify distant cousins. Family tree analysis then pinpointed a suspect whose movements aligned with the crime timeline, solving a decades-old case. Platforms like MyHeritage.com have revolutionized criminal investigations by forming extensive genetic networks. When individuals submit DNA for ancestry insights, they may unknowingly aid in solving crimes. These databases can identify connections as distant as third or fourth cousins, offering critical leads where traditional methods fall short, thus opening new avenues for law enforcement. Genetic matching leverages predictable DNA inheritance patterns. Parent-child relationships share 50% DNA, making identification straightforward. First cousins share 25%, offering strong leads. Third cousins share 3.125%, often sufficient for identification. Even fifth cousins, sharing 0.195%, can be crucial. This logarithmic decrease in shared DNA still provides vital links in solving crimes. Genetic genealogists identify DNA matches by finding individuals sharing significant DNA segments with crime scene samples. They construct ancestral lines, building family trees back to common ancestors, and track descendant branches to pinpoint potential DNA sources. Candidates are narrowed down by age, location, gender, and other case-specific factors using historical records and social media. Genetic genealogy has revolutionized cold case investigations. The Golden State Killer, Joseph DeAngelo, was identified through a relative's DNA. Terry Rasmussen, linked to the Bear Brook murders, was traced across decades. April Tinsley's case saw resolution after 30 years with John Miller's identification. These successes highlight the transformative power of genetic genealogy in criminal justice. The forensic breakthrough in our case was achieved by isolating the perpetrator's DNA from a mixed blood sample. Specialized techniques identified skin cells left in footprints, providing a genetic profile. This, combined with corroborating evidence, confirmed the suspect's identity, highlighting the importance of persistent evidence preservation over decades. The evolution of DNA technology has revolutionized cold case resolutions. Traditional short tandem repeat analysis has been enhanced by advanced methods like single nucleotide polymorphism testing, which examines vast genetic markers for detailed profiles. This precision enables effective genealogical matching, crucial for identifying suspects from challenging samples, showcasing the synergy of modern forensic science. Genetic genealogy pinpointed a family, leading investigators to eliminate suspects through alibis and geography. A previously unnoticed suspect emerged, aligning with case details. Surveillance collected discarded DNA, confirming a match before contact. Traditional methods, like interviews and history research, complemented genetic leads, culminating in an arrest that resolved a 30-year-old case. Cold case resolutions offer profound psychological relief for victims' families, allowing them to process long-suspended grief. Justice served aids emotional healing, though complexities may require support. Communities experience collective relief, restoring faith in justice systems. For investigators, solving these cases brings professional satisfaction and closure, often motivating retired detectives to volunteer in pursuit of long-sought answers. Prosecuting cold cases involves navigating legal challenges like statute of limitations for related charges and ensuring evidence integrity over time. Prosecutors face obstacles with faded memories and deceased witnesses. Expert witnesses play a crucial role in explaining complex genetic genealogy to jurors, ensuring the testimony is clear and withstands cross-examination. Genetic investigations raise significant ethical concerns, particularly around privacy. Individuals may not foresee their DNA aiding criminal investigations, questioning informed consent. Balancing crime solving with privacy, platforms now require explicit opt-in for law enforcement use. Legal frameworks are evolving, with courts setting precedents on reasonable use of genealogical databases in criminal contexts. Nanopore sequencing enables DNA analysis from minimal samples, revolutionizing cold case investigations. AI-assisted analysis accelerates suspect identification by automating genealogical research. Phenotypic prediction allows for visual profiling from DNA, aiding in suspect identification. Legal standards are evolving to balance investigative needs with privacy, adapting to technological advancements and new legal precedents. Artificial intelligence and deepfakes pose significant challenges in forensic investigations. Genetic genealogy aids suspect identification, but raises privacy concerns. Artificial intelligence video analysis enhances footage review, yet deepfakes can manipulate evidence. Voice recognition helps identify suspects, but artificial intelligence voice synthesis can create false evidence. Digital forensics recovers data, but artificial intelligence can generate misleading digital footprints, complicating truth-finding efforts. A brutal murder left behind bloody footprints, containing both the victim's blood and the killer's deoxyribonucleic acid. Initially, the investigation stalled due to technological limitations, but evidence was meticulously preserved. Modern deoxyribonucleic acid extraction techniques isolated the perpetrator's deoxyribonucleic acid, and genetic genealogy built family trees leading to a suspect. 30 years later, justice was finally served. Over 250,000 unsolved homicides in the United States since 1980 hold preserved evidence, with 70% potentially benefiting from advanced DNA analysis. Forensic genetic genealogy has resolved over 500 cases since 2018, offering hope to families and communities. As technology advances, even the coldest cases may reveal their secrets, promising justice and closure.